So today we have to discuss complete the first another example of the limiting reagent and then proceed with the method of expressing concentration and then move towards the next chapter. Okay.
Okay, sir. Yeah.
So in case of limiting reagent or limiting reagent or limiting reactant, limiting reagent or limiting reactant. So in case of limiting reagent or limiting reactant, what we will say, for example, we have a question that 100 gram of 100 gram of hydrogen react with 100 gram of oxygen. 100 gram of hydrogen react with 100 gram of oxygen. 100 gram of oxygen react with 100 gram of oxygen to form, sorry, here what it will form, to form water. So first question is, which is a limiting reagent? Which is limiting reagent? Which is limiting reagent? Which is limiting reagent? Second one is, which and how much component remains unreacted? And third part is, how much water will be formed? Can you try this?
Yes, sir.
Just do this question. This is a most important concept.
So oxygen is a limiting reagent
Yeah.
And then H2O formed is 6.25 moles.
Yes.
And then the component remain unreacted is hydrogen, and then the amount is 75.
Okay. Yeah. So now this topic is clear to you. Any no confusion.
Yes, sir.
Okay. So let us now start with a new topic, method of expressing concentration. So in short, we will discuss here method of expressing concentration. So in case of method of expressing concentration, methods of expressing concentration. So there are various methods of expressing concentration. First of all, first one is percentage composition. What is this? This is a percentage composition. So what is this? What will be this value? Percentage composition. So in case of percentage composition, this is mass by mass percentage, mass by mass by mass percentage, and that is equal to mass of component divided by total mass into 100. Okay. Second one is mass by volume percentage. So in mass by volume percentage, mass of component divided by total volume of solution multiplied by 100. And here third one is volume by volume percentage. So what is volume by volume percentage? That is equal to volume of component divided by total volume into 100. Is this clear?
Yes, sir.
No. Second method of expressing concentration is normality. What is normality? It is denoted by L. And so here normality equal to number of gram equivalent absolute divided by total volume of solution in ml multiplied by 1000. Now, as you know how to calculate the number of gram equivalents, this is simple. So, number of gram equivalents of a component can be calculated as given weight upon equivalent weight. Also, equivalent weight of any component can be calculated as For acids, it's molar mass divided by basicity. For bases, molar mass divided by acidity. For salts or cations, it will be molar mass divided by charge on cation, and last case is anion, so it will be molar mass divided by charge on anion. Okay,
Yes, sir.
now after this, as we see here, what is basicity? So basicity is the, simply we can say, number of H positive ions, number of H positive ions released by an acid in aqueous or molten state. Whereas, but is acidity, and acidity is number of OH negative ions released by an base in aqueous medium. Now after this, as we are calculating here equivalent weight, and after calculating the equivalent weight we can find easily number of gram equivalents, and if we can calculate number of gram equivalents, then it is easy to find the normality. Now normality equation is N1 B1 N1 B1 equal to N2 B2, N1 B1 equal to N2 B2, and for mixture N1 B1 plus N2 B2 equal to N3 into B1 plus B2. Okay,
Yes, sir.
where N1 is the normality of a one solution having volume B1, N2 is the normality of second solution with volume B2, then normality of final mixture, it will be some N1 B1 plus N2 B2 equal to N3 into B1 plus B2. So we can calculate from that. Now next one is second method of expressing concentration we have is molarity, capital M, and molarity equal to number of moles of solute, total volume of solution in ml multiplied by 1000. Whereas if we take it as a If we are calculating it as a liter, then no need to multiply with the 1000. Got it?
Yes, sir.
No. Again, so no. Number of moles of any component can be calculated as number of moles of solute equal to given weight upon molar mass or given volume upon total volume or given number of particle divided by Avogadro number. Like that, we can calculate the number of moles. Then, after calculating number of moles, we can easily find the molarity. And molarity equation is M1B1 equal to M2B2. Whereas for mixture, what will be the again M1B1 plus M2B2 equal to M3 into V1 plus B2. Okay.
Yes, sir.
Similarly, this is for the mixture. Again, third method is molality. And as you know, molality is the best method of it is the best method of expressing concentration. It's the best method of expressing concentration and denoted by small m. So molality equal to number of moles of solute divided by total weight of solvent in grams multiplied by 1000. And with same formula we can calculate the number of moles of solute. Okay.
Yes, sir.
Now, why molarity is the best method of expressing concentration? Molarity is the best method of expressing concentration because molarity does not depends upon the temperature. As molarity, as you know, molarity depends upon the weight of the solvent. It depends upon the weight of solvent. And we know weight depends upon the sorry, molarity depends upon the weight of the solvent, and we know weight does not depends upon the temperature. Whereas normality molarity depends upon the volume of solution, and we know volume depends upon the temperature. We are doing this portion in detail by because in maximum portion in next part in maximum portion these concentrations are being used like this, like the chapter of equilibrium. In equilibrium chapter it will be used. Also concentrations we are using in the solution chapter also of grade 12th. Okay, and these are the important chapter. From here numerical answer questions can also be formed.
Okay, sir.
Okay.
Yeah.
Now next part is here mole fraction. Fourth method of expressing concentration is mole fraction. So mole fraction x What is mole fraction? It is the fraction of the component. It is the, or we can say, fraction of component is the ratio of number of moles of component, number of moles of component to the total number of moles of solution. Okay, total number of moles of solution. Got it?
Yes, sir.
Now here, in case of mole fraction, if a comma b are two different components, are two different components, are two different components with Na and Nb number of moles. Okay, then in such case, mole fraction of component A equal to Na upon Na plus Nb, and Xb equal to Nb upon Na plus Nb. Also remember, also remember, mole fraction is mole fraction is Xa, mole fraction Xa or Xb is always less than equal to 1. Is always equal to less than 1. Okay, so in this case also sum of mole fraction of each component is equal to 1. Sum of mole fraction of each component is equal to 1. Got it?
Yes, sir.
This is how we can find the mole fraction. And now, very important part next, another portion, ppm, that is also known as parts per million, parts per million. So ppm equal to parts of component, parts of component, that may be weight or volume, divided by total volume, or total part of component, total parts of component 10 is to power 6. It will be 10 raised to power 6. Got it? Now, after calculating ppm, okay, and you can also send me your dots whenever you are getting it, any type of dots, then you can share me your dots also. Just keep practicing question, and if you require daily basis questions for the practice, then you can say me. I will share you on the WhatsApp. I can share you WhatsApp sheets for the daily practice problems.
Okay, so can you like share it, like few questions?
Yeah, I will share you on these topics, that the topics we are doing right now.
Okay, okay, sir.
Yeah, sure. So here, ppm, parts of the component divided by total parts of component into 10 to power 6. Now, next part is the relation between vapor density and molar mass. Relation between vapor density and molar mass. So, what is vapor density? Vapor density is equal to molar mass divided by 2. Vapor density equal to molar mass divided by 2. And very, very important here, relation between relation between percentage of solution, molar mass, density, percentage of solution, molar mass, density, and molarity. So here molarity equal to percentage into density into 10 over molecular mass. This is the relation to find the molarity. Now, again, here, relation between normality and molarity. So, always normality equal to molarity into valence. Okay, normality equal to molarity into valency. So, this is the relation between molarity and valency. Got it?
Yes, sir.
Yeah. So, next one is, after this method of expressing concentration, empirical formula, molecular formula concept, mole concept, and then limiting reagent or limiting reactant portion. Next one is, now we will do the questions here. So now the questions are like this: molality of molality of water is molality of water is what will be the molality of water? So nothing is given. So we know density of water at STP equal to 1 gram per ml. Okay. So if total volume of solution or total weight of solution is equal to 1000 gram, then number of moles, total weight of solution is 1000 gram, then number of moles is equal to how much? It will be 1000 upon weight of solution is 1000 gram, and in which all is water. Water itself is a solvent. So its number of moles will be 1000 divided by 18, and this value comes out to be 55.55. And molality equal to, we have taken the weight, so it is 1000 gram. So molality will be equal to 55.55. Simple. Similarly, there is another question. Find the, or we can say, molarity of 98% H2SO4 solution having density 1.1 gram per ml, having density 1.1 gram per ml. Option A, molarity will be 1.1. Option B will be 11. Option C will be 22. And option D will be 5.5. What will be the answer?
So 11 is the answer.
Yes, because directly we will use the formula molarity, molarity equal to percentage into density into 10 divided by molar mass. So here nothing to do. 98 percentage density is 1.1 into 10, molar mass is 98. It is cancelled. So correct option will be B. Okay. Now again here 5.2 molar solution of methanol have mole fraction of methanol is option A 5.2, option B 0. Yeah, 0.52, option C 0.8, okay, option D 0.85. So here this option cannot be there because always mole fraction is less than 1. So this option is cancelled from here. Now in case of 5.2 molar solution of methanol, we have to calculate the mole fraction of methanol. So what will be the value? What will be the value? So here number of moles of methanol, if molarity is 5.2, then number of moles of methanol is, it is 5.2. So for molarity by weight of solvent, that is solvent is water, is equal to 1000 gram. Number of moles of water is 1000 upon 18. So this value comes out to be 55.55. So here mole fraction of methanol is number of moles of the component divide total number of moles of solution. So it is 55.55 plus 5.2. It's 5.2 divided by 60.75. So when it is divided, so here, sorry, it is, so it will be 0.0, not 0, it is 0.0. So this value comes out to be approximately D 0.085. Okay, okay, Asia. It is approximately equal to 0.085. Got it?
Yes, sir.
No. Next part is after this. Next question. That question was previously asked in the JEE exam. When 450 ml of 1.5 molar solution is mixed with 550 ml of 1.2 molar same solution, what will be final concentration of the solution? Okay.
Yes, sir.
Yeah. So what will be the value?
Sir, is it 1.335?
Yeah. So how it will be calculated? M3 equal to 450 into 1.5 plus 550 into 1.2 divided by 1000. That will be the okay.
Yes, sir.
Next, but will be normality of 2 molar H3PO4 solution.
Sir, is the answer 4?
So here normality we can calculate molarity into valency. So in case of H3PO4, OH, OH, OH. So here N equal to 3 means basicity is equal to 3. So normality equal to 2 into 3. This is 6 normal solution. Got it?
Yes, sir.
No. Next one is another question. Now, next one is but will be but will be molarity of molarity of solution having density 1.2 gram ml such that molarity of solution is 3 molar. What will be the value? Yes, solve this. What will be the molarity of the solution having density 1.2 gram per ml such that molarity of solution is 3 molar? So what will be the solution for this? So see here, molarity. So number of moles equal to 3 and weight of solution equal to 1000 gram. Now density equal to 1.2 gram per ml Therefore, mass upon volume equal to 1.2. We have to calculate volume. So volume equal to 1000 upon 1.2 equal to V. Got it? Therefore, molarity equal to 3 upon 10,000 divided by 12 into 1000. These are like this. So this is 3 into 12 upon 10, and it will be 3.6 molar. Is this clear?
Yes, sir.
So like this, we can calculate these molarity equation solutions